Section 6.2, we're going to use proportions to solve geometry problems. And in the last lesson, 6.1, we used the cross products property, which says A times D equals B times C. But we're going to use some other properties of proportions, and first we're going to talk about them. So some additional properties of proportions is the reciprocal property. The reciprocal property says if two ratios are equal, then their reciprocals are also equal. So if we do this example with use a specific example to highlight this. If we take two fractions that are equal, that's a proportion. So like 2/3 and 4/6, those are equal to each other. Well, their cross products would be 2 times 6 right here and 3 times 4, and those are both 12. So if we look at the reciprocals of this, and we flip both fractions, we'd have 3 times 2 would be equal to 6 times 4. That is still true. And again, we can tell it's true because if you look at the cross products, they're still equal. The next property talks about if you interchange or change the means of a proportion, then you also form another true proportion. So remember, the means are these right here. So if we exchange the C and the B in this proportion, we'll also have a true proportion. So if we start out with the original proportion, 2/3 equals 4/6, that's our A over B equals C over D. And now if we change these two around, we would have 2/4 equals 3/6. And again, if you take a look at those cross products right here, you get 12 and 12, and over here you also get 12 and 12. So the cross products are still equal. The last property of proportion is if you add the value of each ratio's denominator to its numerator, then you also form another true proportion. So again, let's go back to our original proportion of 2/3 equals 4/6. So now if I add the denominator to the numerator, so what that means is I'm going to add 3 to this one and add the denominator of 6 to this one, and it's going to give me another true proportion. It's going to give me 5/3 equals 10/6. And again, if you look at the cross products here, you get 12 and 12, and you get 30 and 30. So both the cross products are equal. They don't have to be the same necessarily, but 12 equals 12 and 30 equals 30. So you still get another true proportion. So now let's see if we can kind of use those and do some examples together. So in the diagram, it tells you that AB over EF equals BC over FG, right? 3 true proportions. So we could write it with the letters itself, but let's go ahead and put the values in. So AB is 6 and EF is 10. It tells you that that ratio is equal to BC, which is 3, and FG, which is X. So that's one way to write a true proportion. That's the one that they gave us right here. But now we can take and do the reciprocal of each. So now we could go 10/6 equals X over 3. So let's take a look at those cross products. Now this cross product is 6X, and this cross product right here is 30. So we have 6X equals 30. If we look at the cross products of the second one, we have 30 equals 6X. So we have the same thing. We have 30 equals 6X, and those are the same. And the third way we can write this proportion, well, we could exchange those means. That's probably more common. So if we exchange the means, that means that we are going to exchange from this original proportion, we're going to exchange these two. So that's going to give us 6/3 equals 10/X. And again, if you look at what that gives us, it gives us 6X equals 30 for those cross products. So, moving on. Now we're going to use those to copy and complete the statement. So it says if 6 over x equals 24 over y, then 6 over 24 equals what? Well, what happened here? Well, they moved the 24 down here. So that means the x has to go up there. That's exchanging the means over y. In the second example, you have 7 over 10 equals x over y, then 10 over 7 equals what? Again, what they did here is they did the reciprocal. So 10 over 7 would equal y over x. Now we're going to decide, using the properties that we've learned, can we say whether this is true or false? Well, we have x over y equals s over t. That's your true proportion. So then is x over s equal t over y? So they moved the s down here. They're exchanging the means. So that means the y should be up here. So this should actually say x over s equals y over t. So this is no, this is false. The second example. If x over 4 equals 6 over 8, then x over 6 equals 4 over 8. So they moved the 6 down here, so the 4 should come up there, and it did. So this is, yes, this is true. So in example 4, we're going to set up those ratios and actually use it to solve. And this is similar to what we did yesterday. So it says SR over RQ equals ST over TU, find TU. So this is what we're trying to find here. So SR, that's 3. RQ, that is 4. It tells us that that equals the same ratio as ST, which is 6, over TU, which is X. So we just get 3X equals 24. And so TU, or X, equals 8. So TU equals 8 units, since that's what we called it. Pretty simple. Here's another one, but always be careful of your letters together. But go ahead and see if you can set this one up. If you call this X, this should be X over 12 equals 24 over 18. So now when we solve for x, we could reduce that if we want, but we would get x equals 16. So again, BC equals 16 units. On this example, you have to read carefully because they are saying that HI, which is 21, over GH, which is 14, is in the same ratio as JKX over KD12. No, this is not the one that is tricky. And so go ahead and solve that and see if you got it right. You should have gotten JD equals 30 units. These are pretty easy. All right, so well, and in fact, going back to this one, this was the one that we had to pay attention that we were making sure that we were finding the whole length JD because our X here is equal to 18, but notice they want the whole thing JD. So that's what I wanted to point out on that one. Okay, our last example here is using some of our proportion and also using ratios and making sure we're in the same units. So it says a model of a Sherman tank has a scale of 1 to 16. So that means that the model compared to the actual, the model is 1 foot and the actual is 16 feet or whatever units it is. So this is our ratio of model to actual. It says the length of the actual tank is 584 centimeters. What is the length of the model? So for part A, we're looking at model over actual is equal to 1 over 16. So that's our model to actual. What do they give us? They give us the length of the model here. So that's going to go on the top. We want to find the length of the model. That's what's the missing piece when we know the length of the actual tank, which is 584 centimeters. So now when we cross multiply and solve, we would get that our X value here is 36.5 centimeters. And I know that you can solve that easily. So let's look at part B. Part B says the width of the model is 16.375 units. So this is the width of the model. What is the width of the actual? So again, if we use model over actual is 1 to 16, that's going to be the same as the model to actual in this ratio. And here they gave us the width of the model is 16.375 over X, or you could use Y or something else. But when we cross multiply and solve here, we're going to get that our width is 262 centimeters. And our last example, part C, it says the actual tank stands 9 feet tall. What is the height of the model in inches? Okay, so here you have different units. You have to be careful. But again, always use model to actual, or you could flip them around, but make sure they're in the right position. So our model to actual is 1 over 16. We want to find, it's actually easier to convert your units before you do any math. So since we want the height of our model in inches, we actually want to find the height of the model in inches. So I'm going to put my actual in inches. And so 9 feet is equal to how many inches? Well, there's 12 inches in each foot, so I multiply by 12, which would give me 108. So now when I solve, I'm going to get that my X, or my height, is equal to 6.75 inches. So this lesson is pretty straightforward. It's just using some of the same things that we use in the first lesson in chapter 6. And that's the end of 6.